Okay, let's do some work with some composite functions. So composite functions mean we're going to have multiple functions and we're going to add or subtract them depending on what type of functions are defined here. So let's say f of x equals 2x plus 3, g of x equals negative x squared plus 5, and h of x is equal to negative x. Then determine the following. So what I do for each of these examples is if we're going to create a composite function or something that's composed of multiple functions together being added or subtracted, then let's just arbitrarily name it j of x. So j of x is just a placeholder to mean we have some arbitrary function where we want to add or subtract to equal this. So according to what we've defined above, f of x was equal to 2x plus 3, g of x was equal to negative x squared plus 5, and then h of x was equal to negative x. Now, what do we get if we combine this? Well, we have 2x minus an x on the end there, so we're going to get x. We have 3 plus a 5, which is going to give us 8. And then finally, we have that negative x squared. Now, let's just finally rearrange this so that we say j of x is equal to negative x squared plus x plus 8. That just means all we've done is rearranged it so that we have descending powers of x, and we've simplified it as much as we can. Now, we could always factor this, but in the case of this, we just want to determine whatever the composite function is. If we look at example B, we're going to do the same thing, except what we notice is that we're going to be subtracting to make g of x. So if we go to this example here, we have, first of all, f of x was equal to, from above, 2x plus 3. We can put this all in brackets, 2x plus 3 minus g of x, and we had a negative x squared plus 5, which was all of g of x, so we have to put subtract and then everything that was g of x in the brackets, and then same with h of x, is h of x was equal to negative x, so I'm going to make sure to put that in the brackets. Now what we should notice right away is that we're going to see a negative and a negative is going to form a positive, and a negative is going to form a positive. So before we do that, we want to ensure that we account for the negative on each of the terms. So I'm going to start by writing out 2x plus 3 because that was our f of x. Now we have a negative times a negative x squared is going to give us a positive x squared. And then a negative times the negative to 5 is going to give us a negative 5 here. Now let's do the same thing with the last one here. We have a negative times the negative. That's going to give us a positive x here. Now all we have to do to get j of x is just combine these all together. So we have 2x plus an x on the end, that's going to give us 3x. Then we have plus 3 minus 5, that's going to give us negative 2. And finally, we have plus x squared. So when we state j of x in a final equation, we can arrange it in terms of descending powers. We have x squared plus 3x and minus 2. And yet again, we could factor it or see if we could factor it to simplify it a little bit. But in this case, our simplification is just, let's just add and subtract the terms until we can create them in terms of powers. And then we can always arrange them in descending powers like this. Now, finally, let's do another example here where we have h of x, which we knew was a negative x, plus f of x was equal to, I believe, the 2x plus 3. Yeah, 2x plus 3. And then finally, on the end, we subtracted away the negative x squared, and attached to that was plus 5. So if we do some work with the simplifying here, well, a negative x, that just means we have a negative x here. Then we add the 2x plus 3 that were a part of f of x. But then yet again, we have to distribute this negative to both of these two terms on the g of x. So we have plus x squared because the negative times the negative x squared gives us a positive. And then yet again, the negative times the negative or positive 5 is going to give us negative 5 here. So then therefore we get a g of x, which is equal to, we only had one x squared, negative x plus 2 is just x, and then positive 3 minus 5, that gives us negative 2. And we have it fully simplified. Now let's just focus on some new notation here. Instead, let's say I want to represent plusing and minus using a composite bracket like this. So I can say some function is equal to f plus g with x, which means that we have two functions in terms of x where they're being added together. So I can actually restate this as h of x is equal to f of x plus g of x. And I could do the same thing with subtraction or addition. So suppose that this was a negative instead here. Well, then we could draw an arrow and say h of x is equal to f of x minus g of x. Same idea. Whatever the sign that is in that composite bracket, we can subtract or add whatever it may be, and then they're both in terms of x, which is what that second bracket means right here. Now let's just do a couple examples to represent this. So they say determine that g of x given f of x is equal to 4x minus 7, and we're given some h of x. So what I'm going to do right away is I'm going to state out if h of x is equal to x squared minus 2x, well, I'm going to say h of x is equal to f plus g in terms of x from our above statement, because we want to reference the first equation. The second one was just for an example, but in this case, we want to reference this equation here. So if I state it in terms of this, well, I have h of x, which is x squared minus 2x, is equal to f of x plus g of x, according to our form. And now what are these two? Well, we have x squared minus 2x, again for the h of x, and then in terms of f of x, we have 4x minus 7 plus g of x. Now to get g of x alone, we're going to subtract away everything in the brackets here. So we subtract 4x minus 7, that entire thing. It's going to cancel on the right here. And then we're going to have x squared minus 2x minus 4x. And then the negative and negative is going to give us a positive 7 if we move a negative to the other side. And this is all equal to g of x. Finally, we just have to rearrange in terms of descending power or combining what we can. So I have g of x is equal to x squared minus 6x plus 7. Yet again, we could factor, but in this case, we just wanted to combine them into simplified terms according to adding the composite functions. Let's do one more here with part B. So now we have h of x is equal to negative 2x squared plus x plus 1. I'm going to say h of x is equal to, let's say in this case, it's defined as f minus g in terms of x. So we're just doing the second example from above, which I will outline in red here. So instead, we're pretending that there's a subtraction sign between. Well, if I do that instead, I'm going to have negative 2x squared plus x plus 1, which is h of x, f of x, which was defined above as 4x minus 7, and then we have subtract g of x. Now in this case, what I want to do to make g of x positive is I'm going to add it to the other side here. So I'm going to say plus g of x, and I'm going to add or subtract, depending on their sign, all the rest of these terms over. So I'm going to say plus 2x squared minus x minus 1, and that's just undoing the operations on the left here. So we can get rid of this one, get rid of this one, and then now they just swap places. So we have g of x, because it was added to this other side, that's going to be equal to 4x minus 7, and then plus 2x squared minus x minus 1, because what we do to one side, we do to the other. So these are actually happening to both sides, g of x and the other term. Now, let's simplify this. Therefore, g of x is equal to, we have 4x minus an x, which is 3x. Then we have a negative 7 minus 1 is negative 8. And then we have a positive 2x squared. Now, I'm just going to rearrange these in descending powers so that I have my highest degree first. So I have 2x squared plus 3x and then minus 8. And we're done.